going to cover section 4.3, which is right triangle trigonometry. And we're going to look at the same thing that we did in section 4.2, but we're going to make our way out of the unit circle and take those triangles out of the circle and just look at them as triangles. And then we will be getting the 6 trigonometric functions for all, and then we'll answer some questions. This section is not too long. I'll try to make it a little fast, but if you guys think I'm going too fast, let me know. So here we have the triangle if we were to consider the standard position of this angle here, remember it starts on the positive x-axis. It goes in the counterclockwise direction. This is the terminal side. So that angle happens to be pi over 3, and pi over 3 is equivalent to 60, okay? If you forgot how to do that, remember the unit conversion factor pi over 180, or 180 over pi. If you're converting from radians to degrees, you will use this unit conversion factor to cancel pi. So we agreed that that is going to be pi over 3 equivalent to 60. So if we want to take the sign for that, we will look at the opposite side, and we already know that we call that side just y for the vertical coordinate. And if this is the unit circle, then the hypotenuse is equal to 1. So we have y over 1, or just y. So remember, the opposite side is always the one right across from the angle. And that was the definition of sine, the ratio between the opposite and the hypotenuse. So let's go to the next slide. Okay, now similar to what I was saying the other day, that if we were to, you don't need to do this, but if you were to draw concentric circles around this one, and we were to make triangles that were like bigger, just because we are comparing the ratios of those triangles, the trigonometric ratios end up being the same once you simplify. So for that, let's look at this one here. And we have 4 triangles here on this side. And if you see, what could you guys tell me about them?
Similar.
They are similar. So to be similar, they have to have the same angles, right? So let's see if it's true. All of them have a 90-degree angle. Yes, do we agree?
Yeah.
Same angle. So the exact same angle, all 3. And then this one, we don't know what it is, but we know it's called theta. And so it's theta for all. So we assume it's the same, right? That's the reason why they name it the same. If they wanted to indicate that they were different, they could have named them theta sub 1, theta sub 2, theta sub 3. But right here, they're all the same. So if the first 2 angles of a triangle are the same, then the third one must be the same as well. So first thing for similarity. Second thing, what else do we need to have for similar triangles? They must, the sides, they're not the same, right?
That's congruency.
Proportional. So yes, the congruency will be all same sides and same angles, congruency. So when the sides are only proportional, then we call them similar. All right, so if we go for the same function, and here we're going to talk about tangent. And so the tangent of an angle, let's use this as an example. So here we have theta. This one opposite, like if you were shooting an arrow from that angle, that's the opposite side always. And so that's A. In this case, the adjacent side is the one that actually forms the angle. And then, of course, the hypotenuse is always going to be the opposite to the biggest angle. In fact, for any triangle, the biggest angle is always opposite to the biggest the biggest side is opposite to the biggest angle. So the hypotenuse is always opposite to the 90-degree angle. Okay, so if we look at this triangle and we try to find the tangent for theta, we're going to be using the opposite divided by the adjacent. Okay, so we're going to be looking at the 3 for opposite. It's right here, 3 over 2, 3 halves. Now the bigger triangle is going to be opposite sides, so the tangent will be 6, and then over the adjacent side, so that's 6 over 4, and that reduces to the same, which is 3 halves. Now let's look at the little triangle. The opposite side is 1.5, the adjacent is 1. And what happens if you multiply that fraction by 2 over 2? So 2 and 2. So it turns into 3 over 2. So as you can see, so far all 3 of them are proportional because the ratios can be turned into the exact same fraction. Here we have the opposite is 4.5 and the adjacent is 3. So the ratio will be 4.5 over 3. And if you divide by 1.5, you will get 3 halves. 1.5 on top and the bottom. So you get 3 halves. So yes, do you all believe me? Those triangles are similar, correct? Yeah? Yes. Same angles, proportional angles. So that's why when we go to circles that are bigger than the unit circle, the ratios are the same. So let's go to the third slide. Well, actually, let's just do this quickly just as a review. And so we already covered that the sine of an angle will be the length of the opposite over the hypotenuse. The cosine is going to be the length of the adjacent over the hypotenuse. And the tangent is going to be the length of the opposite over adjacent. And then how do we call the relationship between sine and cosecant? Reciprocal, very good. And so it makes sense that we flip those, right? So hypotenuse over opposite. Cosine is the reciprocal of secant. So hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So that will be adjacent over opposite. Okay, so we really need to learn this. And I know you guys are very good with the acronyms, so the sine, the cosine, and the tangent, right? But we don't call them that. That's just semantic. They're called trigonometric ratios. Okay, so find the value of each of the 6 trigonometric functions. It's very simple. So the sine of theta is going to be the opposite over the hypotenuse. So I want you guys to just look at the numbers and write them down. Now there's one that we're missing here, right? We have the measurement of the adjacent. This is the adjacent because it forms the angle, right? And then the opposite is the one that is right across from the angle, okay? And so I'm going to write here the definitions, but I want you guys to work that. And then how can we find C?
Pythagorean.
Very good. So C squared is A squared plus B squared. So C is equal to the square root A squared plus B squared. So let's do that. Most of the time there's going to be a side that is missing. And if you guys notice on the next example, the missing side is the adjacent. But we'll figure out how to get that in a minute. It's also with Pythagorean, but there's going to be a slight difference. So here we have the square root of A squared, which is 5, so 5 squared plus 12 squared, and that'll give us the square root of 25 plus 144, which will be the square root of 169, which is 13. So C is 13. So now you guys have everything. This is the hypotenuse. Okay, so for side, well, I'll give you like a minute. Okay, while you guys finish the example 1, I'm going to go ahead and find B. So if we have that a squared plus b squared is equal to c squared, then to solve for b squared, it will be c squared and not plus a squared, but what? Minus a squared. This is very important, guys, because I've seen exams that everything is good except that the way they got b was wrong, okay? And so one way for you to check is that the hypotenuse always has to be the longest side. If you get something different, then you did something wrong. The sides have to be shorter than the hypotenuse. Do you guys know the triangle inequality? So if I was to add a plus b, the two sides that are not the hypotenuse, they will have to be greater than the hypotenuse. So that is also another way to figure out that you don't have a real triangle. Okay, so here we're going to get, what is C? C is 3, 3 squared minus 1 squared, so that is 9.
Minus 1.
9 minus 1, so that would be the square root of 8, correct? Okay, and so that, we're going to turn it into, I'll write it down here, so if, what is that going to be? B? If B is the square root of 8, tell me that again, Sebastian?
2 square root of 3. No. 2
times
4.
2 times 4, those are the factors. Why we use 4? Because 4 is a perfect square. So then the 2 will stay inside the radical. The 4 comes out as the root of 4, which is 2. So it's 2 times the square root of 2. Okay, so let's review the example 1. So all of you, hopefully all of you get to answer a question today. Where are my other cards? Okay, I don't know where they are, so we're gonna have to use this one. But I do have it. Okay, so sine. Who has the ratio for sine? Okay, Sebastian.
5 over 13.
5 over 13. Thank you. Okay, Arturo.
Cosine, right?
Cosine, yes.
Okay, so it's going to be 12 over 13.
12 over 13. Okay, who's gonna give you the next one? Okay, Jen.
5 over
5 over 12. Okay, Elena, go next, and then Valera. So cosecant.
Oh, gee, hold on.
Just look at this one.
Oh, 13 over 5.
There you go. Okay, who else was Valeria, and then I'll take David and then I. All of you will get a chance, okay? We're not going to do doubles. Yeah.
13 over 2.
14 over 12. You almost didn't get it.
I know, sorry.
And David?
12 over 5.
12 over 5. Very good. Okay, now let's do the next 6. I'll write them down so you can check. Let's do the next 6. Get ready so you can answer one.
Get the next 6 ready?
Yes.
Okay.
But if you already answered one, you're going to have to take a break. Yes, there's going to be some rationalizing going on. Do you guys have any issues with finishing 4.1? 4.2, okay. We'll address them after the break. Okay, I'll give you guys a few minutes. You're going next. You're going next. Okay, yeah. So checking the answers, we got sine 1 over 3, cosine 2 square root of 2 over 3. For tangent, we got 1 over 2 square root of 2, and so now we got to rationalize it. Instead of multiplying by the whole denominator, we're only gonna multiply by the irrational part, which is the square root of 2. This is the square root of 2. So
Oh, yeah.
whatever we do to the bottom, so there's no need to multiply by 2 times the square root of 2. That's what I'm trying to say. Whatever we do to the bottom, we do it to the top, and here we will get straight across, remember, so square root of 2 over, here we still have this 2, and then we have the square root of 2 multiplied by itself, so being square, right? So you know that that is going to cancel the square with the square root, but what happens between the answer of that and the coefficient here? They multiply because they're in parentheses, or here they're not. There's nothing in between them. So if we multiply 2 times 2, what do we get? 4. So this is the square root of 2 over 4. However, we should use this easy form before rationalizing to give the cotangent, right? Okay, who's going to give me cosecant? Nathan?
3 over 1, or 3.
3. Very good. Secant? Who wants to do secant? Secant? Arturo, you already? Good. Someone who doesn't have a card has to give me the answer. Even? Go ahead, go ahead. Okay. 3 times square root of 2 over 4. Okay, now let's show everybody how you got that, okay? So you started by putting the 3 over the 2 square root of 2, yes? And then you multiply by the square root of 2, top and bottom. So that's very good. And then here you had 2 times 2, so you got 4. Very nice, very nice. Did I give you your card? Here you go. So what we did was oh, you want to do the next story? Okay. So what we did was getting the reciprocal of this of cosine. So that's why it was 3 over 2 times square root of 2. And then after we rationalize this one, the square root of 2 cancels. We get a 2, so we get 2 times 2. Okay, Isaac Reina, what is the next one?
2 square root of 2.
Okay, that was pretty easy, right? If we just look at the one without rationalizing. There you go. Okay, great. Good job, guys. Okay, now we're going to find we already know what the sine and the cosine of 45 is, right? Yes? But we found that with the unit circle. We're going to find it with triangles. So based on the special triangle, the one that has 90, 45, and 45, if this is x and this is x, we don't know what it is, this one will always be x times the square root of 2. So that means that if this is 10 and this is 10, then this will be 10 times the square root of 2. Now here, they have given us a triangle with 1 and 1, and so therefore this will be 1 times the square root of 2 by following the pattern of this triangle. So let's use this triangle here to get the 6 trigonometric functions. And I won't give you a card for those because you already know. So I'm just going to write them down quickly so we can get more homework time today. So sine, if we look at the opposite over the hypotenuse, it would just be 1 over the square root of 2. And after you rationalize, you should get square root of 2 over 2. Yeah, do we agree with that? Now for the cosine, it's the adjacent, so 1 over the hypotenuse. We rationalize, and that will be the square root of 2 over 2. Tangent is going to be the opposite over the opposite over the adjacent. So that would be 1 over 1, which is 1. Now for the reciprocal identities, cosecant, we're going to get the reciprocal, but before rationalizing, so that is square root of 2. Reciprocal of cosine is secant. And that will be also square root of 2. And then cotangent, what is the reciprocal of 1? Also 1. And that's it. We got it. Okay, now let's look at the other triangle, the other special triangle, which is the 30, 60, 90. So we're calling you?
Yeah.
Oh, you were. Okay, so what we have here, actually, I'm gonna draw this. Okay, I'll just draw over it. So let's start with a triangle which has all the sides are equal, and all of them happen to be the angles, interior angles are also equal. So how do we call those triangles? Equilateral, very good. So if this side was a 2, this side will also be
2.
a 2. And if this side, and what will this side be? The whole base. A 2, if we take the whole base. All right? Yes? Do we realize that? Okay, now what I'm going to do is erase a few things. And so I'm going to cut that triangle in half and just focus on one half of that triangle. And so I'm going to get that off. Now, if I cut my angle here, this is a bisector. So then my angle, instead of being 60, it just happens to be 30, right? Half of 60. And then here, I just want half of the base. So that's why we just have the base equals 1. Okay, but you guys get why the hypotenuse is still 2? Yes? I hope so. Now, with special triangles, just like we have this model here, that's the 30, the 30, 60, 90. In general, it goes like this. So here is the 90-degree angle. Which one is the shortest side? The one standing vertical or flat? Right. Vertical is the shortest. So if I was to call that a 1, then this, no, I'm sorry, the hypotenuse will be twice as that. So it will be a 2. And the other side is going to be 1 times the square root of 3. So that's how it always works. What is bigger, a 2 or a square root of 3?
2.
The 2, right? So it makes sense that it's opposite to the 90. Okay, so now that we know how we can get the 30, 60, 90 triangle from the equilateral. So this is a 1, we already got it. And this is the hypotenuse. Remember, hypotenuse is always opposite to the 90. And for this type of triangles, if I was to put x here, this will be 2 times x, always the double. And this one will be x times the square root of 3. It could be helpful in geometry. Okay, so now let's look at the 60 degree, and the opposite to 60 is going to be square root of 3. And the hypotenuse is 2. Cosine, we need the adjacent to 60. And so that's going to be here, the one forming the 60-degree angle, that's adjacent. 1. Hypotenuse is 2. Okay, now let's look at the sine of 30. Okay, so now let's focus on sine of 30. And so I want you guys to look at this angle here. What's opposite to 30?
1.
1. And what is the hypotenuse? 2. So this 2 happen to be the same. Because they are co-function. identities. Okay? And so if we take the cosine of 30, let's think about it. What is the side adjacent to 30? Look at this angle right here. Don't give me the hypotenuse, give me the side that is forming the angle. Is the hypotenuse and what else? The adjacent right here, and that is equal to? Square root of 3. And what is the hypotenuse? 2. So the cosine of 30 and the sine of 60 also co-function. Anytime that you have complementary angles, like 30 and 60, or like, what is the complement of 20?
80.
80.
Yeah.
Yeah, is it? Yeah, they have to add up to 90.
70
No, it's 70.
Oh, yeah, 70. Oops, my bad.
for a second there.
Okay, what is the complement of 45?
45.
So it makes sense, right? They have the same. Sine of 45 is the same as the cosine of 45. Yeah, we all know that. Okay, so next slide. Okay, this is just another way to memorize them. Remember what I told you? You could go like the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2. And then if you want to find for 90, you could even do that, which is pi over 2. So let's add those two columns here. And so that will be the square root of 4 over 2, which is 2 over 2, which is 1, or 90 degrees. But we already knew that because you guys pay attention to the unit circle, right? And you know that 90 degrees is right here. What are the coordinates of that point? 0, 1. Yeah, isn't it true? And sine is the what? Sine 1. Okay, now when we go in reverse, let's find, this will be the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2. So this one should be the square root of 0 over 2, which is just 0. And isn't it true that the cosine of 90 is 0? Yes? Do we all copy it? Okay, great. And then let's find tangent. Well, tangent is, it could be found by dividing the sine over the cosine, exactly, because that is the quotient identity, like a division or ratio quotient. And so if we take here 1/2 and divide it by the square root of 3 over 2, and we could use that sandwich multiplication method, so that will be a 2 over the square root of, I'm sorry, over, it looks very messy here. So it will be, oh no. Okay. Okay, so let's do this again. So it was 1/2 for the sine over the cosine, which is the square root of 3 over 2. And so this will be 2 over 2 times the square root of 3. Cancel the 2's, we get 1 over the square root of 3. Rationalize the square root of 3. Oof. So this is the square root of 3 over 3. Yay, that's what we needed. Okay. And so that's how you will find all the tangents by, if you have the sine and the cosine, that's pretty much all you need. In fact, if you have the sine, that's all you need. Because remember, what a sine tells us? The opposite and the hypotenuse, right? So can't we get the other side just with 2 sides of a triangle? Of course we can. So all you need to know is 1 of the 6, and you can find anything. That's why trig is so beautiful. Okay, so it's almost time for your break. Let's just go ahead and take notice to the co-function identities, just like we did the, let's write this example here, the sine of 30 degrees is the same as the cosine of, what is 90 minus 30? 60. That's what it means. All right? Complementary angles and cofunctions. So notice that when we talk about reciprocals, sine goes with cosecant. Are we clear on that? And cosine goes with secant. That is reciprocal. But when we talk about cofunctions, look how they are paired up. They're not the same, okay? Please acknowledge that. So the sine goes with the cosine, and the tangent cotangent is the same for both, reciprocal or cofunction. But the change here happens with secant goes with cosecant. Okay, so it's very different. So when if you guys ever say the word opposite in my class, I'm gonna have to correct you because sometimes you guys use that interchangeably to mean reciprocal. So I'm gonna be very sure to correct you when you say that. Opposite, that means opposite sign. Reciprocal, that means the numerator and denominator flipped or switched. Cofunction are the ones that have the same value, trigonometric ratio. Okay, so I'm gonna pause here, let you go on break. If you wanna just turn on your laptop, so when you come back, you don't have to wait for that. Yes. So the angle of elevation, make sure you copy the definition. This is the line of sight. And anything above the line of sight of this person, above, that will be the angle of elevation. Like when you look up to look at a plane, there's always a horizontal line. That will be your line of sight. And then the way, how far you tilt your head, that will be your angle. We cannot do that, that's insane. But we'll figure it out in a minute. Okay, and then angle of depression doesn't really mean that the angle is depressed. It's just simply line of sight, and then you look down. And so that angle right there, angle of depression, and that is below the line of sight. Okay, so for example 6, we have here a building, and we have a person who is, you guys see him right here? It's very tiny on your handout. And so he's surveying something there, right? And so he measures an angle of elevation of 22 degrees. And so the transit is 5 feet above the ground and 300 feet from the building. So from here all the way to here is 300 feet. And then what we need to find the building's height. And so we want to find the height from here to the top of the building. So when we measure that, we are going to have to consider the 5 extra feet right here, okay? This is 5, this is A, and we're looking for H. Yes? Are we okay with that? So, let's see, what else do we know? We don't know anything at all. Hold on. Okay, so the reason I asked you to get a calculator is because we're going to have to use a little function, which is going to be called an inverse function of a trigonometric function. And we're going to cover that later on. In fact, there's a whole section called that, inverse trigonometric function. So what we're going to do here, and do not confuse inverse with reciprocal. for different things, okay? So, let's see. We have here 5, and we have A. So if we were talking about this angle right here, what do you guys think that side will be called? Would that be the adjacent, the hypotenuse, the opposite side of 22? What is it? Opposite. So we have something that is opposite, and we know one number. The 300, correct? Yes, we know 300, and that will be the adjacent. Now, what trigonometric function of the 6 will have opposite divided by adjacent? Tangent, okay. So that's actually going to be the tangent of the, and you don't have to use theta because we actually know what the angle is. The angle is 22. Now let's see what we could replace with opposite. And so that's going to be A plus 5. And what is the adjacent? 300. Let's just use, should we just use H? We could. I don't know why if I have to use A. Okay, gotcha. We're going to have to use A because this is how the triangle is formed. So the line of sight of the guy is actually 5 feet above. So at the end, we're going to have to add the 5 feet. Do you guys notice this dash line? Yes? So that is above the 5. And so our triangle is coming from here. So that's A. And so just because the angle was formed without counting the 5, we're going to have to just use A for our variable. Okay? So for the opposite side, we only use A. At the very end, we will add, because we know the height, the whole height is going to be A plus 5. Okay, so we'll do that at the very end. Okay, so going back to this here, we have the opposite is A, and then we have tangent of 22. Perfect. What can we do to solve for A? Multiply by 300 because 300 here is dividing, so we'll do the inverse operation. So A is 300 times the tangent of 22 degrees. Okay, do you guys know where tangent is located at? Okay, so if you don't know, there's a button called Trig, and it's to the left side of number 7. So you press that, and you can see the function for 22. I'm going to open my calculator, but that's going to take a while, so you guys can type it faster than me. Another thing that we have to be careful of is that you are using degrees, not radians. So you're going to have to be switching back and forth from degrees to radians, depending on the problem. So to do that, just to make sure you're in degrees, you could go to Menu, Document Settings, okay, so let me tell you again. So the main screen, go to 5 for settings, and then Document Settings, and then it will be the second option. You change that to degree. Okay. Now that you have done that, you can go back to your calculator and type in the 300 plus, I'm sorry, not plus, times tangent of 22. So what did we get from there?
121.208.
Okay. 121.208. Very good. And so now to find the height, we're going to add 5 to it. So that would be 126.208. We're talking about feet, right? Yeah? Yes? Do we confirm? Yes? Okay. Very nice. Okay, so the last problem. What do I always forget your problems? I don't know. Okay, let's do that one. So checkpoint 6. The irregular blue shape represents a lake. The distance across the lake is A is unknown. To find this distance, the surveyor took the measurements shown in the figure. What is the distance across the lake? Okay, so what can we do with opposite and adjacent? Tangent again, yes? So the tangent of 24 degrees is going to equal A for opposite over adjacent, which is 750 yards. So to solve for A, that will be equal to 750 times the tangent of 24 degrees. And that will give us an answer. Now the very last one is the one that you will have to use the inverse function. We'll go back to the answer on that one. Does anyone have it? 750 times tangent of 24.
333. 333.9.
33.
3.
Another 3?
0.922.
Okay. And the units here are in
Yards.
Okay. The last problem, we have a building that is 21 meters tall. I'm just going to draw it. This is 21 meters. It casts a shadow of 25 meters. Find the angle of elevation of the sun to the nearest degree. So imagine that someone is here. And the sun is over here. Okay, it's the same drawing, but you're not always going to have the drawings, so you're going to have to learn how to draw them. And so we do that, and this is the angle of elevation. We don't know what it is, so I'm going to call it theta. And we have an opposite side, and we have an adjacent side. What is the relationship with opposite and adjacent? Tangent. Oh, sorry, I already wrote the answer. Okay, so now we don't know the angle. In fact, that's the question. Find the angle. So if we get the ratio of the two coefficients, the opposite is 21, the adjacent is 25. Okay, now there's a little function called, we had tangent here. And then here I have 21 over 25. You know, every function has an inverse, something that will undo it. So the inverse of tangent is actually called tangent inverse. And so when we do that, the tangent and the tangent inverse cancel, and we just get theta. But whatever we do to the left, bless you, we have to do it to the right. And there's actually a little function in that same button, that trig button. Well, my calculator never opened. Press trig, and you will see there's a tangent with a little power of -1. That means tangent inverse. I want all of you to press that button on your calculator and find it. That's the one that we're gonna, that's the one that we're gonna cover more of those problems later on. Okay, so this is the end of the lesson. So once we get that answer, we'll be good to go. To the nearest degree. Who has it? Teresa, you have it? What is it?
40.0303.
Say that again.
40.0303.
0303. So we round it to the nearest degree. So we're going to say that is 40 degrees. Let me give you a plot. Okay, guys, so this is the end of the video. Work on your homework. Let me know if you have questions.